Hey guys, so today you're going to be doing a little worksheet called Prokaryotic and Eukaryotic Cells. So we've already went through, we did all the notes. I uploaded this into Cami and I'm hoping, crossing my fingers, that Cami will work with us today. If you're in class, I'm going to give you a paper copy of this so that we don't have to fuss with it. But if you're online, again, I'm hoping that it works. You want to have this right here, the text box is what you want to have highlighted, and you'll just be able to click and you'll be able to type in there. Okay, so that's how that will work. You can change the coloring of your font if you want to. Please, make sure that I can see it. If you write it in white, I'm not going to be able to grade it. So prokaryotic and eukaryotic cells. Do all cells have the same structure? And obviously we know that they don't, based off of the notes that we went over earlier this week. So let's start with the very beginning here. Now, most of this you will not actually need to read, but you will need to be able to interpret the diagrams and just, observe them. So an efficiency apartment is a one-room apartment. This one room is where you sleep, eat, shower, and entertain your guests. It all happens in one room. It is a simple way of living in a small space. This would be like New York. A mansion is a large, complex living space with many separate rooms. There are rooms for cooking, eating, sleeping, bathing, reading, watching TV, entertaining guests, exercising, and storage. The rooms in a mansion are constructed for the specific things you would be able to do. You can live in a simple efficiency or complexity. In this activity, we'll be looking at cells that are as simple as a one-room efficiency apartment or as complex as a mansion. So model 1 is going to start off with the basics. These are the 3 types of bacterial cells. You can have a coccus, which is a sphere, spirillum, which is this spirally looking thing, and a bacillus, which is a rod shape. So you would be labeling the diagrams from model 1. So you would label each one of these cells exactly what they are. And I'm looking down here at question 1 if you're wondering where I'm coming up with these words from. What is represented by the small dots found in each of the bacteria? So you're going to go through, okay, here's some small dots, and there's, look at that, an arrow pointing to them. Ribosomes. So you would write ribosomes for number 2. What is the name of the outermost layer that forms a boundary around the outside of each cell? Outside of each cell. So let's see. Right here I see cell membrane, but there is this big, thick line. So I want to keep on going until I find an arrow pointing to the thick line. Cell wall. So that must be the cell wall. So cell wall would be number 3. And number 4, how is the DNA described and what does this mean? So look for DNA. Here it is, free-floating DNA. So how is it described? It's described as free-floating. And what does that mean? Well, think about it. If you say that something is free-floating, what does that mean to you? Hopefully you're thinking it means, well, it's not enclosed in anything. It's not encased in anything. It just kind of relaxes and chills in there. Not surrounded by anything. You're kind of understanding what we should be doing here. You're just going through and reading those diagrams. All the internal structures are suspended or floating in what substance? Okay, let's see. Internal structures are suspended. Well, they're all chilling in this big goopy area called the cytoplasm. I'm not going to go through and do all these questions for you, but I just wanted to show you what you should be looking for. You'll go on down, do model 2, which is animal and plant cells. Answer those questions based off the diagram. Model 3. Now this part you are going to have to read. It says word part and what it means. So using the chart in model 3 to determine the type of meaning for the word prokaryote. So pro means before. Karyon is nucleus or kernel. So if you just say exactly what that is, it means before nucleus or before kernel. That's it. What does the word eukaryote mean? Eu means true. Again, karyon means nucleus or kernel, so that means true nucleus. By comparing, or based off the word definitions, label the cells in model 1 and 2 as prokaryotic or eukaryotic. And by comparing model 1, What structures are the same in both prokaryotic and eukaryotic cells? So here you would actually probably want to say model 1 and tell me what model 1 is. In model 2, you can identify them just like that. Let me keep on going. Refer to models 1 and 2 to complete the chart. All you're doing is writing yes or no in the box. So if they have a cell membrane, for example, bacteria cells do have a cell membrane, so you would put yes. Animal cells, they do have a cell membrane, you would put yes. Whoa, I don't know why it does that sometimes. And plant cells, they have a cell membrane. Now I could have just said all cells over here, but I kind of like to see the yes going across, because then I know that they have it. Write a definition from prokaryotic using only the knowledge you've gained from this activity. That means I don't want you to look it up online. I want you to come up with a definition that makes sense for you. And you'll continue on answering those questions. Until you come all the way down here to the very end. Complete the chart by describing the function and structure in each cell. So this is the cell right here. It is a root hair cell from a plant. You're going to tell me what is the function of a root hair cell in a plant? And are there any adaptations that it has? So you can compare this cell to some of the other cells and let me know if you notice that there are any differences. What makes this root hair cell capable of taking in water and not getting damaged by the soil particles, whereas this muscle may not be able to do that, or this nerve cell may not be able to do that? Alrighty, and that is all we are going to do for today. Have a nice weekend.